Okay, this video is all about how to approximate area, and there's lots of different methods on doing this. We're going to talk about one method in particular called left-handed rectangular approximation method, or I just call it LRAM, L for left, it's easier to remember. And what this is all about is finding the area of a shape where you don't have a memorized formula. For instance, if I give you a rectangle, and I ask you to find the area, it'd be really easy as long as you know the length and width. You'd say area equals length times width. But if I was to make up some random shape, like maybe it even kind of looks like a rectangle like this, but then it has some weird curve. And I'm just making this up, and I said find the area of this shape. It's not like you're going to be able to come up with some formula like length times width to figure it out. Triangles, you can use the 1/2 base times height, but this isn't a triangle. It's really weird. It's curvy. So we need some way to figure out what's this area equal. And so to do that, we have an approximation method. What we're going to do is take this weird looking shape and we're going to put it on a graph. And we're going to figure out the area that way. So let's do an example, one with an actual equation. And let's say we have the graph, something more familiar, like y equals x squared. Y equals x squared is just like a typical parabola. So I'm going to sketch a graph of a parabola here for a second. Looks something like this. And what if I said I wanted to find the area between maybe the points at 1 all the way out to 4? 1 to 4 means we're looking at a really small section of the graph from here to here. So the area of this shape. So to figure out that area, what I'm going to do is I'm going to break it up into pieces. I'm going to actually kind of zoom in here, and I'm going to redraw this graph and just focus in on the shaded region. So let's redraw this, but bigger. So same graph, zoomed in. We're focusing from 1 to 4, so the parabola goes something like this. And we'll say here's 1, here's 2, here's 3, here's 4. If I want the area from 1 to 4, I'm going to break it up into little rectangles because I know how to find the area of a rectangle. It's length times width. And I'm going to do that using something called an LRAM. LRAM stands for left. I'm going to use the left side. If I start at 1, 1's on the left of all these numbers. I'm going to go up to 1 and put a point on the graph. Then I'll go to 2, I'll go up to 2, put a point on the graph. 3, up to 3, put a point on the graph. And what I'm going to do with all these points is I'm going to build these little rectangles. I'll go back to 1 here where 1 started. I went up and put a point here. And then I'll just put a straight line across, and I'll make this little rectangle right here. And then I'll go up to 2 here, make a little straight line across. There's another rectangle. And I'll go up to 3, and I'll go across, and I'll make a third rectangle. And then I'm done. I stop at 4, so there's just 3 rectangles that are going to fit under this space. Well, if I want to approximate the area, I can add up length times width, length times width, length times width for each of these little rectangles. So area is going to equal the length times the width. Well, the first rectangle goes from 1 to 2, so has a length of, or a width of 1. And it goes up to this point on the graph. This is the graph of y equals x squared. So this is at 1, so it's going to be 1 squared, which equals 1. This is a point at 1, comma 1. Which means when I'm doing my length times my width, length and width are going to be 1 and 1. Plus, I'm going to add the area of this rectangle, which also has a width from 2 to 3, so it's a width of 1. And its height, if I measured the length here, goes up to 2, so that's going to be at 2 squared, so we're at 2 comma 4. You plug 2 into x squared, you get 4. So 1 times 4. Plus the last one, you can already guess, has a width from 3 to 4, so a width of 1. All these widths are going to be the same. And then it has a height at 3 going up, so 3 squared puts it at 3 comma 9. So it has a height of 9. So the area of the little rectangle is 1 times 1, so 1. The medium rectangle is 1 times 4, so 4. And the largest rectangle is 1 times 9, so 9. So the area is 1 plus 4 plus 9, which is 14. So my guess for area of this shaded region over here that I shaded completely is that it has about an area equal to 14. If you're looking at our little rectangles, you can tell that our estimated area isn't perfect because we left out these little gaps. Remember, we're zoomed in though. If I was to zoom out, these little gaps are really, really small. So this is a good estimation, a really good estimation. And if somebody was to ask you, is it an overestimation or an underestimation? Hopefully your response would be under because we left out a little bit of space. So actually the area is probably a little bit bigger than 14. So this is an estimation, it's an underestimation. Underestimation. And that's typically how you do an LRAM. You break it into little rectangles and add up the length times width. We did this with 3 rectangles, so we would say that the number of rectangles, a lot of times we denote it as n. N stands for the number of rectangles. And we would say that we use 3 rectangles, so n equaled 3. If I wanted to get a better answer, I would have tried to make smaller rectangles. I would have made like 6 or 7 or 8 or 9 rectangles in this little bit of space, chopped it up into even smaller parts, and that would be an even better representation. So our next example is going to be the same problem with more rectangles. So let's redraw. We've kind of ran out of space here. Let's take that same graph of y equals x squared. We'll go from here to here, y equals x squared. And let's find the area from 1 out to 4. So we'll put 2 and 3 somewhere in the middle here. But instead of using the 3 rectangles that I did earlier, I'm going to split it up into like 6 rectangles. So n equals 6 rectangles. So think about what that means. From 1 out to 4, I have to break it up into 6 little pieces. So I'm going to have to split this up and make it really, really small, which means I'm going to start using in-between points, like in-between, like at 1.5, 2.5, 3.5, and build these little tiny rectangles. We're still doing an LRAM. So we're going to start on the left side. The left rectangle starts at 1 and goes up. Then I'll go to 1.5 and I'll go up. And then 2, I'll go up and put a point. And then 2.5, 3, 3.5. But since I started on the left, I'm actually not going to go up to 4. I'll show you why in a second here. Let's build all these little rectangles. If I go back to the start at 1 here, I'll make a little line that goes across. There's my first rectangle. And then I'll go up to 1.5, make a little line that goes across. There's my second rectangle. Then I'll go up to 2, make a line across. There's my third rectangle. Then I'll go to 2.5, make a line across. There's my fourth rectangle. And then I'll go up to 3, make a line across. There's my fifth rectangle. And my last one, my sixth rectangle, because I wanted 6 rectangles, is I go to 3.5, go across. And I know these don't all look perfect, but you get the idea. 6 little rectangles crammed into there. They're evenly dispersed. I'm splitting them up evenly. So if I asked you how wide are each of these rectangles, you'd say, well, I went from 1 to 1.5 to 2 to 2.5 to 3 to 3.5. So they're each 0.5 wide, or a half wide, half of a unit. So we're going to add up length times width, length times width, length times width for every single one of these rectangles. So like look at the first rectangle here. We know the width is a half, but the length depends on the function. It's x squared, and we started at 1, so it's going to be 1 squared. So we have a point here at 1, 1, just like we did in the last problem. So the area of this thing, I'm going to write it out. Area equals length times width, or width times length, either or, 1/2 times 1. That's that first little red rectangle. Plus my next rectangle also has a width of 1/2 but my height is x squared based on this, so it's going to be at 1/2. It's going to be at 1.5 here, so it's going to be 1.5 squared. So why don't I just write in here 1.5 squared, whatever that is. Plus my next rectangle, this red one, it's at 2, so it has a length or a width of 1/2 and a height at 2, which makes it 2 squared if I put it into x squared. Plus the next rectangle has a width of 1/2 and it's at 2.5 squared. Plus the next rectangle is at 1/2 and it's at 3 squared. You see the pattern. And then we went to 3.5 plus, so we're going to add 1/2 times 3.5 squared. And I'm going to stop. I'm not going to do one for 4 because there's only 6 rectangles. So if you count these up, I've got 1, 2, 3, 4, 5, 6 rectangles right here. So now I just got to purely do the math, probably plug it into a calculator. So if it's easier for you, which this is what I would do, since every single one of these has a 1/2, pull the 1/2 out in front and then just add them all up. We have a 1 plus a 1.5 squared plus a 2 squared plus a 2.5 squared plus a 3 squared plus a 3.5 squared. And at this point, I'm going to go grab my calculator and type that in. I don't know that off the top of my head. It turns out I did it on a calculator just a second ago, and it's 17.375, 3 decimal places. So that's my guess for area. It's my estimation. And it's still, if you look at the graph, it's still an underestimation. We left out little spaces. They're very, very small. But underneath the curve, if you were to zoom in and take a close look, we left out a little bit of space. So this is still an underestimation. It's probably a little bit bigger than 17.3. Maybe it's like 18 or something like that. We don't know for sure. But we're close. So the more rectangles you use, the better your estimation. And the whole point of an LRAM is to figure out area by building these little tiny rectangles. And the directions when you're doing homework, they're going to tell you. Use 4 rectangles or use 6 rectangles, use 10 rectangles. So you're just going to follow the directions to kind of figure it out. And hopefully that helps. The next video is going to be about LRAM.